In this video, I will explain the concept of slip. So earlier we have seen what is an edge dislocation line. So we will look at this concept of slip with the help of this edge dislocation line. For this, let us first consider some plane of atoms like this. So this is the plane of atoms. So if I draw a line here, okay, so this is the plane of atoms. So I can draw another plane here and another plane here, another plane here like this. Okay. So I have now drawn the atoms on all these planes. So these planes looks like this. So this is the planes in crystal. Uh, so I am going to make a cut on this plane like this. So let us call this 1, 1. This is 2, 2. This is 3, 3. This is 4, 4. 5, 5. This is 6, 6, and 7, 7. Okay, here, let me try to make a cut. So, like this, only up to here. That means I am breaking the bonds here throughout this plane of atoms. I am breaking the bonds here. Then I am trying to push this uh, plane with respect to the bottom half plane by applying a force. So let us see what happens. So what you will find is you can see this, mm, you can see the bottom half plane will remain there, okay, and this plane just gets moved. So since the breaking of bond is only up to the fourth plane, it moves here. Then after that, there is the bonds are not broken, so it will remain like this. Okay. So if I draw a line like this, so this will be uh, something like this. Okay. So this will be 1, this will be 1, this will be 2, this will be 2, this is 3, this is 3, this is 4, and this is 4, and this is 5, and this is 5, and this is 6, this is 6, and this is 7, and this is 7. So this is how the plane of atoms looks like. So what you will find is that you can see an extra half plane atom here. So that means there is this bottom edge of this half plane is missing. Okay, you can see the bottom edge of these half planes are missing. You can find a defect that is called the edge dislocation line. But this is not quite stable. So what will happen is that, okay, so this is your bottom plane. So this plane, this top, the first plane joins with the second plane here, and here the third plane. So this joins with the third plane here, and this joins with the half plane here, and here this, oh, this plane and this plane. Okay, here this plane and here this plane. 7. Okay. This just remains like this. Okay. So this is what happened here. That means the first plane makes bond with this bottom plane, that is 2, and the second plane here makes bond with here the third plane, and third plane top third plane makes bond with the fourth plane here, and you can find a dislocation. This bottom edge of this half plane of atoms is missing, so this contributes to a dislocation line if you consider the plane. So this defect extends into the paper throughout this line. So this is called an edge dislocation line. So you can see that here a slip occurred. Okay, that means the dislocation line traveled towards right. So you can also observe that this slip occurred only up to here, and it doesn't occur here. So if you draw a plane, the the top view, you can get it like this. So that means there is a line here, and you can see that here the slip is, that is the shifting of the planes towards the right. So this gives you the magnitude and direction of slip, the magnitude and direction of slip. So you can find that. So in this region, if you look at the top portion, this is corresponding to this the transition between 4 and 5. So here, up to here, the dislocation, the slip has occurred. Here you have the slip region. On the right side, you have the non-slip, no slip region. And here, this is the magnitude and direction. We will try to look at the magnitude later. Magnitude and direction of slip. Okay. And this extended only up to this region. And the top view, this is the dislocation line. So this is the dislocation line, because this is the, here we are seeing an there is an extra half plane. That's why this is called a dislocation line. And there is one more thing we need to note here. Uh, if you draw a plane here, so you can see that here this is called the slip plane. Okay, this is the plane on which the slip has occurred. That is why this is called the slip plane. Okay, and this distance gives you the magnitude and direction of the slip.